The truth about France's Fuelless rocket engine, what they're not telling you. An investigation into the hidden environmental costs of clean space technology. By now, you've probably seen the headlines flooding social media. France just built a rocket engine that works without fire, and revolutionary fuelless propulsion changes everything. The posts are going viral, promising clean space travel with no combustion, no moving parts, and no fuel tanks. It sounds like a miracle breakthrough. Clean technology finally conquering space travel. No more polluting rocket fuel, no more environmental damage. But there's something they're not telling you in those viral posts. And when you dig into the details, what you find should make every person who breathes air very, very concerned. What this fuelless engine actually uses. Let me be clear about what France actually built. According to the technical specifications, these plasma engines work by taking gas, specifically xenon, krypton, or argon, turning it into plasma using electromagnetic fields, accelerating that plasma and then ejecting it to create thrust. That ejected gas, that's the fuel. It gets consumed and lost to space forever. So despite the marketing, this isn't fuelless at all. It's just using a different type of fuel, one that comes from a source most people never think about. Our atmosphere. The numbers tell the real story. NASA's ion thruster technology, which uses the same principle, consumed approximately 870 kilograms of xenon propellant over just 5.5 years of operation. The Dawn spacecraft required 425 key 937 labs of xenon for its mission. These aren't small amounts. We're talking about hundreds to thousands of pounds of atmospheric gases being ejected into space, never to return. Where these abundant gases really come from. Here's what they don't mention in those viral posts. Xenon doesn't just appear in tanks magically. According to atmospheric scientists, xenon is produced commercially by the fractional distillation of liquid air and is isolated as a byproduct of the cryogenic production of oxygen and nitrogen. The concentration in our atmosphere is around 90 ppb, that's 90 parts per billion, or about 1 part in 10 million by volume of dry air. Think about that ratio for a second. To get 1 liter of xenon, you need to process 10 million liters of air. The industrial process is staggering. 1. Compress millions of cubic feet of air using massive facilities. 2. Cool it to liquid form using enormous energy inputs. Fractionally distill to separate components by boiling points. 4. Extract and concentrate the tiny amounts of rare gases. 5. Remove permanently from natural atmospheric circulation. This isn't small-scale extraction. Industrial air separation plants process atmospheric gases on a scale most people can't comprehend. And with global xenon production at only 50 or 60 tons annually, while space industry demand is dramatically increasing, we're looking at a massive scaling up of atmospheric processing. The hidden environmental threat. Why mining our atmosphere could be catastrophic. Here's what should keep you up at night. Earth's atmospheric composition has been stable for millions of years. We're talking about 78% nitrogen, 21% oxygen, 1% argon, and trace gases in precise ratios that every living thing on this planet has evolved to depend on. All life depends on this exact balance. When industrial facilities process millions of cubic feet of air to extract valuable components, they're not putting that air back in the same proportions. Oxygen gets sold to medical facilities. Nitrogen goes to industrial applications. Rare gases go to electronics and space industries. What gets returned to the atmosphere? Nobody's tracking that. Why should you care? Because even tiny changes in atmospheric composition can cascade through entire ecosystems. We've already seen this with CO2. Levels increased from 280 ppm to 420 ppm, and we got climate change. Now imagine what happens when we start industrial-scale extraction of the gases that make up the air itself. The cancer pattern. We've seen this movie before. How every clean technology becomes environmental destruction. If you're feeling a sense of déjà vu, you should. We've been down this road before. The whaling industry. Abundant ocean resource. Clean burning whale oil. Result: near extinction of multiple whale species. Deforestation. Renewable timber. Sustainable lumber. Result: climate change and massive biodiversity loss. Fossil fuels. Abundant energy powers human progress. Result: atmospheric CO2 crisis and global warming. Rare earth mining. Clean technology materials, green energy solutions. Result: environmental devastation in mining regions worldwide. Now, atmospheric mining. Clean space propulsion. Abundant atmospheric gases. Result: do you see the pattern? Every time they promise abundance. Every time they claim it's sustainable. Every time we discover we're consuming the resource faster than it can regenerate. Every time we create cascading environmental damage. And every time we don't realize the damage until it's too late. The scaling nightmare. What happens when clean space travel goes mainstream? The space industry isn't staying small. We're looking at satellite mega-constellations requiring continuous propellant resupply, space tourism scaling up rapidly, Mars colonization missions needing massive fuel supplies, deep space exploration with multi-year propellant requirements. Research papers are already warning that the growing number of satellites utilizing electric propulsion units and particularly Hall thrusters is dramatically increasing, resulting in a strain on the availability of xenon propellant. Current global production, 60 tons of xenon annually. Future space industry demand could be thousands of tons. The math is terrifying. To meet this demand, atmospheric processing would need to scale by 100x or more. We're talking about industrial air mining on a scale never before attempted. What happens to our atmosphere when we're processing billions of cubic feet of air annually to fuel the space industry? The life support system. We're about to monetize Earth's atmosphere, not just air, but our entire life support system. This isn't just about air to breathe. Our atmosphere is an incredibly complex system that regulates global temperature through greenhouse gas ratios, protects from radiation through ozone and magnetic interactions, controls weather patterns through pressure and chemical gradients, supports atmospheric life, including bacteria and microorganisms crucial to ecosystems. This system evolved over billions of years. Every ratio, every chemical interaction, every pressure gradient is interconnected in ways we barely understand. And we're about to start mining it industrially. Think about that. We're going to take the life support system that every living thing on Earth depends on, process it through industrial facilities, sell off the valuable components, and hope the balance doesn't shift. We have one atmosphere. There are no second chances. The corporate profit model, selling air, how they plan to make money from your breath. Here's the business model they're not advertising. 1. Take free atmospheric gases that belong to everyone. 2. Process through massive industrial infrastructure. 3. Create artificial scarcity through complex extraction requirements. 4. Sell to space industry at premium prices. Xenon costs 1.7 per gram. 5. Create dependency on atmospheric mining supply chains. 6. Scale up as space industry explodes. 7. Profit from literally selling the air we breathe. They're about to monetize the atmosphere itself. The same pattern we've seen with water, land, forests and fossil fuels. Take something that should be free and abundant, create dependency through industrial processing, then charge premium prices for access. Next, they'll be charging subscription fees for breathing. The alternative path: true energy independence. Technology that actually breaks the extraction cycle. While mainstream science promotes atmospheric mining as clean, there are researchers working on technologies that could achieve true energy independence. Electromagnetic field manipulation for propulsion without ejecting any mass. Resonance-based energy generation that taps ambient field interactions. Self-sustaining systems that work with natural forces instead of consuming matter. These approaches generate energy from field interactions without consuming anything, work anywhere in space without fuel dependency, create no environmental impact on Earth, break the extraction cycle entirely. But guess what? These technologies don't create profitable supply chains, so they don't get the funding or media attention that atmospheric mining receives. What you can do right now: don't let them mine our air without a fight. Ask the hard questions. How much atmospheric processing does your clean space technology actually require? What happens to Earth's atmospheric balance when this scales up? Where are the environmental impact studies for industrial air mining? Why aren't we developing propulsion that doesn't consume atmospheric gases? Demand transparency. Atmospheric impact assessments for all space propulsion programs. Public oversight of industrial air processing operations. Environmental monitoring of atmospheric composition changes. Investment in truly sustainable alternatives. Recognize the pattern. Every time they promise a clean solution that still requires extracting Earth's resources, it's the same destructive pattern repeating. True solutions don't mine anything. Support real innovation. Look for technologies that work with natural forces instead of consuming them. Real breakthroughs don't require mining our life support system. The bottom line: France's Fuelless rocket engine isn't fuelless. It consumes atmospheric gases that have to be extracted through massive industrial air processing. They're not solving the fuel problem. They're just switching from mining the ground to mining the sky. And they're calling it progress. The viral headlines celebrating this breakthrough are missing the most important question: what happens to our atmosphere when we start mining it industrially to fuel the space industry? We're about to find out. And by the time we realize the consequences, it may be too late to reverse them. Our atmosphere took billions of years to evolve into the precise composition that supports life. Do we really want to hand it over to corporations to mine for space fuel?